and welcome to the video on SVM. SVM stands for Support Vector Machine. So SVM or Support Vector Machine is one of the most popular supervised machine learning algorithms which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of SVM algorithm is to create the best line, or we can call it a decision boundary, that can segregate n-dimensional spaces into different classes so that we can easily classify the new data point into correct category in the future. Now the best decision boundary is called a hyperplane. Hyperplane is one of the most important and frequently used terminology while we are going to study SVM. So it is the best decision boundary in SVM. So SVM chooses extreme points or the vectors that will help in creating the best or the optimum hyperplane. Now these extreme cases are called as support vectors. Hence the algorithm is termed as support vector machine. So consider the below diagram in which there are two different categories that are classified using a decision boundary or a hyperplane. So in this diagram, as you can see, the two most extreme points of both the green and blue category are known as the support vectors, and this is the maximum margin or the distance separating those 2 points, and this is the maximum margin hyperplane. This is on the right side we have the positive side of the hyperplane, and on the left side we have the negative side of hyperplane. And here, for the ease of understanding, I'm using a 2D a dimensional space or a coordinate axis, but in real life problems you can have a n dimensional vector space. So this is the basic working of SVM. Now have a look at this diagram. Here what we have some labeled or training data. So we have two different types of images in the data set. One is for cat and another is for dog. So as usual in the machine learning procedure that we follow, let's say we use the 80% data for training the model. This is the labeled data. So each image will have a label whether it's a cat or a dog. So all this 80% of the data will be given to the model for training. Now this new data point, and this will be a non-labeled data point. Once the model is trained, it will be given to this model, and finally based on the patterns that it has extracted from the training data, the model will predict that this new data point it's a cat. So this is how the SVM works, just like any other supervised machine learning algorithm. Now let's study about the different types of SVM. So SVM can be of two types. The first one is linear SVM. Linear SVM is used for linearly separable data, which means if a data set can be classified into two classes using a single straight line, then such data is termed as linearly separable data, and classifier is used as linear SVM classifier. So again, going back to the image, all the data points inside the data set can be just separated by a single linear straight line. So this is an example of linear SVM. Another slightly complex version that we have is a non-linear SVM. So non-linear SVM is used for non-linearly separated data, which means if a data set cannot be classified by using a straight line, then such data is termed as non-linear data, and classifier used is called non-linear SVM. So we can tune the hyperparameters in SVM, and we can fit the SVM function on linear or non-linear data. That is about the coding part, and we'll discuss it once we are done with the theory presentation. So important terms in SVM, the hyperplane and support vectors. So hyperplane, there can be multiple lines or decision boundaries to segregate the classes in n-dimensional space, but we need to find out the best decision boundary that helps us to classify the data points. So this best decision boundary is known as the hyperplane of SVM. The dimensions of a hyperplane depends on the features present in the dataset, which means if there are two features present in the dataset, then the hyperplane will be a straight line, and if three features are present, then the hyperplane will be a two-dimensional plane. We always create a hyperplane that has a maximum margin, which means the maximum distance between two data points, so it can separate the data points very clearly, and we want the best fit hyperplane. And again, the support vectors, so the data points or the vectors that are closest to the hyperplane. So once we have found out the hyperplane, the plane that is separating two different classes, and the data points that are closest to that particular hyperplane that we are using, that is known as the support vectors, which affect the position of hyperplane are termed as support vector. Since these vectors support the hyperplane, hence these are called the support vectors. So let's understand with this practical example. So the working of SVM algorithm can be understood by using, suppose we have a dataset that has two tags, green and blue, and a dataset has two features, x1 and x2. We want a classifier that can classify pair x. Suppose we have a new data point x1 x2 with the coordinates x1 and x2, and we want it to be classified into a green or a blue category. So in this image, now what we can do, suppose it's a 2D space. So just by creating or using a single straight line, we can easily separate these two classes, but there can be multiple straight lines that can separate these classes. So we can have this brown kind of straight line, or we can also have this green straight line. Both these lines are clearly able to separate blue and green classes, but the SVM algorithm helps us to find the best fit line or the decision boundary that we can use. So this best boundary or region is called a hyperplane. So this is the optimal hyperplane based on the distances calculated from the support vectors. So this is where the role of SVM comes into picture. So SVM algorithm finds the closest point of the lines from both the classes. These points are called the support vectors that we already discussed. The distance between the vectors and the hyperplane is called the margin. This is a new term. So the distance between the optimal hyperplane that the SVM is determining and the support vectors is called a margin, and the goal of the SVM is to maximize the margin. So based on the maximizing the margin, this is the concept. So based on that, from whichever hyperplane we are getting the maximum margin, that will be considered as the optimal hyperplane by SVM. So the hyperplane with maximum margin is called the optimal hyperplane. So this is the core concept of SVM. I hope you are very clear with this. Now let's move to the Jupyter Notebook and try to implement SVM. Let us start with the practical implementation of SVM. First of all, I'll import pandas as PD and import numpy as np. Then I'll create one data frame to store the CSV file that we are going to be using for the SVM. So let's call this df is equals to pd.read underscore CSV, and here I'm going to use user data.csv. So let's see what do we have inside our data frame. So the entire CSV file is loaded. Now next thing what we can do, we can separate the dependent and the independent features, basically the x and y that we use. So for x, I can use df of I want age and estimated salary. So these are the two features that I'm going to use for x, or maybe the independent features. And the dependent features that we are trying to use or basically predict is purchased. Now let's see what do we have inside x and y. Okay, so x dot, so age and estimated salary are the independent features, and we have y dot head, the purchased column, that is we are trying to predict. So let's train and split the data set into training and testing. So from sklearn dot model underscore selection import train test split. Now I will make x train, x test, y train and y test. So x train, then I have x test, then y train, and finally y test. This will be train test split, and the features are x and y, and I will use 80% data for training, so the rest 20% will be for testing. So this is done. Now let's import the SVM classifier. So from sklearn dot svm, as we are solving a classification problem, so I will import svc, that is support vector classifier. So it is done. Now let's make the classifier instance. So SVC, and we are going to use the linear kernel that we already discussed in the theory part. So you can change the hyperparameters and tune them and check the results accordingly. For this I'm going to use the linear kernel, and let me run this cell. So kernel, okay, we have made a spelling error, so this is kernel. Now let's train it with the help of xtrain and xtest. So we'll use the fit function, and I'll give xtrain and ytrain. So the model will take some time to train. Once it is done, you will get something like this. Now let's make some predictions. So I'll write ypred clf, and I'll call the predict method, and I'll give xtest over here. So we have all the predictions inside the ypred. Let's see what is there. So ypred, all the 0 1 0 1 0 1 that the model has predicted. So now what we can do, we can check the accuracy of the SVM. So from sklearn dot matrix import accuracy underscore score. So these are the this is the accuracy score metric that the sklearn gives us to check the accuracy of a classifier. So I can write accuracy underscore score, and here I have my y test, and then I'll give my ypred. So it will compare the results that are stored in the y test, and it will also with the results that the model is predicting, and it will tell us the accuracy. So the accuracy that we are getting is about 86.25%. That is actually a pretty decent accuracy for without doing much hyperparameter optimization. So SVM is working quite good on the dataset that we are using. So I hope you are clear with working of SVM and also the practical implementation of SVM. Now let's move to the next video. Thank you.